Hello everyone, welcome to another exciting tutorial, one of the tutorials which you guys have been anticipating for quite some time. In this tutorial, I'm going to show you how to develop your own script to extract the cross-sectional profiles corresponding to each and every section, as you can see over here, using a Python script. Now, if you try to do this manually, it's actually going to take quite a lot of time, but using a Python script, we have managed to extract the cross-sectional profiles in this manner. Now, as you can see, this profile corresponds to this cross-section XS0, and we have about 57 cross-sections. Now, we have managed to extract the cross-sectional profiles for each section, which shows you the elevation along each specified section. And not only this, the script also extracts the XY data for each section into separate CSV files as well, as you can see over here, which corresponds to each cross-section, which you can use to basically create your own cross-sectional profiles based on this X and Y coordinate information as well. So I guess this tutorial is basically going to be a very exciting tutorial for you guys. So without further ado, let's get started with the tutorial. Alright, so to explain to you a bit about the structure of this tutorial, now as you can see over here, I have got a couple of layers. The first layer is the DEM layer, and if you need to extract the cross-sections corresponding to this river network, you might have to extract the sections probably in this kind of a way. That means within certain distances, you actually have to extract the cross sections at certain specified set of intervals like this. Now, if I were to do something like this manually, since I'm using ArcGIS, I can actually use the 3D Analyst tool. Now, to just demonstrate to you how that sections would look like, you can see that I have selected my DEM over here. By the way, if you don't have ArcGIS, just don't worry. You can just pay attention to what I'm doing. This is just to get yourself familiarized with what we're going to do. You can see that here we have one option called interpolate line. So I'm just going to maybe draw one line along this. And now if I use this profile graph tool, you can see that it actually creates the graph. The vertical axis is probably going to be in meters, and you can see that the elevation variation along that line. And if you would like to do it for a different line, for example, let's say if I scroll up somewhere over here, and if I want to know the cross-section profile of this particular section, yeah, that's how it looks. You can see that this probably might be referring to the inward level of the river, I guess. So without doing this one by one, through this tutorial, I'm actually going to teach how to actually develop a tool which can do this fully automatically for all the sections, as you can see over here. Now, let's say that if you manage to extract the sections from section number 0 all the way up to section number 57, and save it into, let's say, an external file, something like a CSV file, and later you can access those files in this manner. And over here you can see one of the examples. For example, we have the X value is basically the distance along the horizontal line, and the Y value is basically the vertical elevation. Now, as you can see over here, clearly reflects the channel, the river channel. And what if you actually want to extract these kind of sections for a multiple number of sections? Doing this by hand would be a tedious task, isn't it? So that's why I have structured this tutorial in a way that you will be using most of the libraries, most of the geospatial analysis libraries which I have taught to you guys for the past few months, I guess, such as the geopandas library, the pandas library, and also rasterio library, because we will be using those libraries to achieve different tasks. For example, we will be using the geopandas library to do certain operations such as reading in the shapefiles. For example, if I want to read in this particular line, I can actually use geopandas library and pandas library to sort of arrange the data in a proper way. And finally, we will be also using the rasterio library because creating the section along one of these cross sections is basically means that you're extracting elevation values from the DEM, and each pixel of the DEM is actually corresponding to an elevation value. So if you extract the elevation values along this section, that means you're sort of picking the pixel values from the DEM, which is our raster. So I cannot think of a better library and an easier library to do that using Python other than the rasterio library. So that's where the rasterio library is actually going to come in handy for us. Alright, so I guess you guys have sort of a general idea about what we are going to do. Now, before jumping into the tutorial, I would like to say that instead of trying to actually perform the tutorial for all these sections, we have how many? Around 57 sections. I would rather actually do the whole process for, let's say, one selected section. Because if we can extract the elevation values along one given section, transferring that script into something that can actually do the same process for a multiple number of sections is actually not going to be a difficult task. It's just a matter of writing another for loop and making the proper arrangements in the script, so that you can actually sort of transfer your methodology into a multiple number of sections. So in order to do that, just keep in mind that we will be using this whole number of sections at a later stage. So just to begin with, just to explain to you guys the theory behind this tutorial, let me create one test section. So let me go ahead to my folder and I'll create a new shapefile. And I'm going to name this as test section. Maybe test cross section. That's going to be a line, a polyline. And the whole thing is currently in WGS 1984 geographic coordinate system. So that's why I have selected that as the coordinate reference system. And now I can go to the edit features and start editing. And from here I'm going to draw one line, let's say one section like this. And I'm going to stop the edits and save the edits. And if I open the attributes table, you will see that actually we have just one attribute corresponding to this line. And by the way, if I open this cross-section shapefile, open the attributes table, you can see that we have 57 sections. All of these are corresponding to each and every section like this. So we'll forget about this for a second, and we'll actually focus on this section for the time being, which is this one. Alright, I guess that's about it for the introduction. In case if you would like to see how the section of this one looks using these ArcGIS tools, actually if you can just draw one section like this and see the profile. Yeah, you can see this is how actually the profile looks. Now let's forget about this in ArcGIS and try to sort of replicate this using Python, and try to sort of create this kind of and try to extract the section using Python. And after that we can transfer it to all of these sections, so we can actually manually alter the sections in the way that we want. So that's primarily the idea of using a scripting language to do the tasks in the way that we want, rather than trying to do them in a way how they have been programmed to us by someone else. Alright, I guess now we can just directly jump into the tutorial. Alright, so I'll be using Spyder as my IDE for the task. So let me go ahead to the file explorer. As you can see over here, I have navigated to the place where I would like to save my .py Python scripting file. So I'm just going to go ahead and right click over here and create a new module. And I'm going to name this as cross section extractor. Alright. So first of all, I'm going to get started by importing some libraries that we are going to use. So first of all, I'm going to import the geopandas library. Then I will also need the pandas and the numpy libraries. Later on during the tutorial, I will be explaining to you where exactly I'm going to make use of these libraries in order to do certain tasks. But for the time being, I think if you guys are following along the tutorial, you can also just get started by importing these libraries. And finally, import pandas as PD. The next thing that I'm going to do is I'm going to read in this shapefile which we created, which is this test cross section. Now if I open ArcGIS over here, this is the line which corresponds to this test cross section. So first I'm going to import this line, and since we have the geopandas library, we can do that quite easily. I'm going to create a variable called, let's say, line. That's going to be equal to gpd dot read file, and I have to specify the path to this file over here, and the name of that is test cross section. Alright, so before going into the further steps, let's run this one and see whether everything runs perfectly or not. Alright, now you can see that it's already here, and now we can just type line and see what happens. We have one attribute, line string. Go to the variables explorer, and over here you can see that, yeah, it's a very simple shapefile with just one attribute. We have the ID and we have the geometry over here. Now, before moving into the next step, I would like to bring to your attention certain things regarding the structure of this shapefile. If I go to the variables explorer, you can see that we just have two columns, out of which this geometry column is the most important one, because this sort of holds the attributes which have been used in order to create this line. Now, if I come to this IPython console and if I try to say line.columns, it will show you I have two columns, the ID and the geometry. And now if I say line, let's say I will try to select the geometry column, and you can see that it's actually listing down all the attributes in that geometry column. Now, since we just have one attribute, it's only listing that one down. So let's say if we want to select this first attribute, what you can say is you can say the line geometry number 0, and that will basically draw us the line. Now, if you go back to ArcGIS, you see that this is basically the same line that you can see over here, but now it has been visualized in Python itself. So let's go back and explore a bit the structure of this geometry attribute. You can see 4 numbers: 101.6, 4.7, 101.7, 4.6. So since this is a line and since we have 4 points, what do you guys might think that these different coordinates refer to? Because you can see that it's very clear, it's decimal degree coordinates, something that looks like XY coordinates. So if someone wants to create a line, you actually just need 2 points, right? You need the starting point and the ending point. And when you just connect those 2 points, what you have is a line. And as you can see over here, it has 4 coordinates. And I think it's fair to assume at this stage that these 4 coordinates might be referring to the coordinates of the 2 ends of the line, isn't it? Now, if I go back to ArcGIS and let's say if I hover my mouse over here, let's say if I stand at this starting point of the line and just focus your attention onto the lower right corner of the screen. Over there you can see that we have 101.6, 4.7, and when I move my mouse cursor over here, you can see that the coordinate changed from 101.6 to 101.7, and the y coordinate, it remains at 4.6. So I guess now you guys get the idea that if I open this again, this 101.6 and 4.7 is basically referring to the starting coordinates of the line, and this 101.7 and 4.6 is basically referring to the ending coordinates of the line. Yeah, something that looks like this. So what I'm going to do is I'm going to extract the starting coordinates and the ending coordinates corresponding to the line. If I go back to the figure, the starting coordinates is basically this one and the ending coordinate is basically this one. So let me create 2 variables. Start coordinates and the ending. Alright, now using the IPython console, let's try to see how we can extract these coordinates. Now if I say that line geometry 0, it gives us the line, and if I say dot chords, it doesn't show us the values just yet, but let's say if I put this into a list, it actually sort of throws the whole thing and then it puts into a list like this. And from here, you can see that it segments the starting coordinates and the ending coordinates into 2 elements of the list. Now, for example, if I try to call the first element of the list, which is by the 0th index, we get the starting coordinates, and if I try to go to the second element of the list, it gives us the ending coordinates. So this is basically going to be my script over here. Yeah, just like that. And now if I run this script and go to Variables Explorer, you can see that I have the start coordinates and the end coordinates. And if you want to check the type of this variable now, you can see that it's a tuple. So let's say that we want to extract just the longitude and the latitude values of the starting coordinate. What I can do is I can just say that start coordinates, and if I try to pick the first one, it actually gives me the longitude value, which is the x value. And similarly, if I say 1 over here, it gives me the latitude value, which is the y value. So in case if you would like to sort of save this into lon and lat, what you can do is you can just pick like this, and that'll basically give you the longitude and the latitude value, isn't it? Okay, so before moving on to the next part, I would first like you all to have a look at this diagram. Now this diagram actually shows you the same section, but in the middle you can see that I have splitted the diagram into a number of points. Now over here you can see the points are located at equal distances. For example, this point is the first point, second, third, fourth, and the fifth point. So what I have done basically is I have marked locations where I can split the point into equal, how many parts? 1, 2, 3, 4, 5, 6, equal 6 parts. So if you specify 5 points with equal distances in the middle, that actually splits the whole line into 5 parts, right? Now if you're wondering why we have to do this, that's basically for this purpose, where when you actually create a section, you just try to specify x and y coordinates. Let's say if you're talking about the starting point is here and the ending point is here, that means if you need to have a section like this, now just imagine that this is the river cross section, for example. If you need to plot the river cross section, you need to have coordinates at each point, right? So each deflection points has its own xy coordinates. So right now you can see that I have only 1, 2, 3, 4, 5 points in the middle, along with the 2 points of the sides. It actually just has seven corners. But if you really need to have a very smooth line, you can imagine now we might have to increase the number of points, right? Let's say if you have 10 points, I can make the curve go a bit more smoother. But if I have 20 points, it's much better. If I have 50 points, it's even better. So that's basically the principle behind that. But to get started, we'll actually stick to 5 points because it's easy to understand rather than working with a higher number of points, right? But later on, we will try to increase the number of points which we can sort of use to split the straight line into a number of sections. Okay, now since that's out of the way, you can have a look at this. Now let's say that since I have provided 5 points in the middle, and then along with the 2 points on the sides, it's going to be 7 points, which means I'm going to split my whole branch into 1, 2, 3, 4, 5, 6 sections, right? And if the length of the whole branch is L, that means the distance from here to here. Now just mind you that this drawing might not be exact according to the scale, but I just want you to understand the math behind it. The distance of one piece will be actually L divided by 6, because we have 6 sections over here. But if you have higher number of points, this number which the L gets divided by also increases. I think you kind of get the idea of that. And let's say if you want to calculate the horizontal distance between a couple of these points. Now from simple trigonometry, actually it can be proven that if you have the distance as L and if you have the points sort of splitting points at equal distances, then even if you consider the horizontal distances, then still the length is actually going to get distributed equally. For example, the horizontal length from this line to this line, it's actually going to be x2 minus x1, right? And if you divide that again into 6 pieces, you actually get the distance of this each individual horizontal section, right? And similarly, you can do that for y as well. So let's say that if you have y2 minus y1, now in this case, let's say this might actually result in a negative number, but if you really want the positive distance, you can just put an absolute value sign, so that will actually give you the positive value. But for this case, just imagine that still, even though this is a negative number, just think of it as a distance. Now in this case, it's y2 minus y1. That's basically going to give you this vertical distance, and we are going to split it because we have 6 equal sections over here. And as you can see, it's going to be y2 minus y1 divided by 6 times, which actually gives you the y2 minus y1 whole distance. So this is simply what you need to understand in order to do this exercise. I hope it's clear for you guys. Now going one step beyond, let's say that I assign a value called p into this x2 minus x1. So the horizontal distance from the starting point until the second point, the horizontal distance will be p. That means 1 times this x2 minus x1 divided by 6. But if you want to find the distance from the starting point, the horizontal distance I mean, all the way up to the second, let's say this point, it's going to be twice the length of p. And for the third point, it's going to be 3 times p. Fourth point, it's going to be 4 times. Fifth, going to be 5 times. And for the final point, it's going to be 6 times p. And similarly, if you are now talking about the vertical distances, let's say I assign a value called q to y2 minus y1 divided by 6. Again, keep in mind that this is actually going to result in negative distances, but for the time being, just consider it as a positive distance. So in that way, you can see that from this level up to the level of the second point, it's going to be just q. Sorry, the first point, if you don't consider the starting point. So similarly, if you want to know the vertical distance from the starting point to the ending point, it's actually going to be 6 times q. And 5 times q over here, 4q, 3q, 2q, and 1q over here. And here it's 0q. Basically, this is the ending point. So this is basically the math that you need to understand in order to proceed with this tutorial. I hope it's clear for you guys. So now let's go back to our coding. Okay, so I'm going to specify one variable called endpoints. Now again, keep in mind that this is the number of points which I'm going to specify in between the starting point and the ending point. Again, if I recall back the diagram, it's like this. You have the starting point and the ending point, and these endpoints refer to the number of points I'm assigning in the middle. And now what I'm going to do is I'm going to calculate the x distance. So let me define one variable called xdist, and that's going to be this n coordinates 0 minus the start coordinates 0. Alright, and the y distance, again keep in mind that x is referring to the longitude and y is referring to the latitude. So the y distance, it's going to be the same thing, but only this time we are going to select the index number 1 instead of index number 0. Alright, so what I'm going to do over here is I'm going to calculate the coordinates of each point in terms of latitude and longitude. So since I want to actually iterate through a number of points, rather than doing this one by one, what I can do is I can actually write a simple for loop. Let's say for I in a range, and I start from number 1, and my ending points is actually going to be the number of points plus 1. Alright, so we do the indentation for this one now. So let's say that means when n is equal to 1, it's still going to calculate the x distance and the y distance, and then it's going to calculate the coordinates of the first point from the starting point, and that's going to be equal to starting coordinates plus this x distance divided by n points plus 1. Let me put a bracket to this one, and I'm going to multiply this by I. I hope you can understand what is the reason why I multiplied this by 1. Now during the first iteration, I is going to be number 1. I is going to be just 1. That means the starting coordinates. Now this one is actually referring to the longitude. The starting coordinates plus x distance divided by the number of points plus 1 multiplied by 1 means it's actually going to get the longitude value of the first point. So let me put another bracket over here, and then I can similarly specify the latitude value, just that we have to change this value to be index number 1, right? And then we provide the square brackets. But now this is corresponding to the first iteration, but during the second iteration this value is going to change to number 2. That means it's actually going to take twice the distance of x and twice the distance of this one needs to be changed to y dist, twice the distance of y. And in the third iteration it's going to take number 3 and then put it over here, which means it's actually get 3 times of the x distance and the 3 times of the y distance. So what I also would like to do is actually, since I have specified the starting longitude over here, I can just say lon append and this point over here and put the longitude and take the longitude value during each iteration and then just append it to this one. Similarly, I can take the latitude, append, and over here take the latitude value and append it to this one. Now I guess you kind of get the idea of what we just did over here, but still keep in mind that it's not going to take the coordinates of the final point, because for example, when you specify this np.arange, now if I show you an example over here, if you say np.arange from 1 up to, let's say, 5, because you think that we have 5 points, so this might actually give us a list from 1 to 5. Actually it doesn't. Instead what it does is it's actually giving us the array from 1 all the way up to 4. So if you want 5 points, you actually have to enter 1 to 6. That's why I increased the number of points by 1 over here. This actually doesn't mean that we are referring to the final coordinate. It's only for the np.arange to work properly according to the number of points that we have here. So after everything is done, what we can do is we just again take this lon, now we are out of the loop, append, and now what we append is the longitude of the end coordinate, and similarly we take the latitude and append it with the latitude, the end coordinate of the latitude. Yeah, now I can just run this one just to make sure that we don't have any errors for the time being. Yes, as you can see now it's actually trying to append things to this longitude and latitude. Now before correcting this at once, maybe it'll be a good learning opportunity for you guys also. Just try to read the error message. It says that the float object has no attribute append. So what it's trying to do is it's actually trying to append things to this longitude and latitude. Now if I try to check the type of this lon or even lat, it's actually saying that it's a float. So if you need to append things to it, you actually have to convert it into a list. So one easy way to convert this into a list would be actually to put a couple of square brackets like this. And now let's say if I say type, yeah, with the square brackets you can see that now it's a list, and now when I run the code it'll run without any issue. Yeah, you can see that it ran without any issue. So let's go to the variables explorer and then have a look at what sort of variables that we have going on here. Alright, right now not much actually. What we can do is we can just open this longitude and latitude variables and see how those looks. So longitude, now you can see that it has extracted the corresponding longitude values for each and every point. Similarly, if you go to the latitude, it has the latitude values for each and every point. That's including the starting point and the ending point. So you see that 0 and 6 refer to the starting point and the ending point of the diagram, but this 1, 2, 3, 4, 5 are actually the points that we define in the middle. So basically we have the coordinates already handy. Now if you can recall actually the structure which I explained at the beginning, if you have the x and y coordinates, now all you have to do is just go back to your DEM and try to extract the pixel value, right? So for each point basically. Now let's say that if you would like to have a much more detailed number of points. Let's say you want to extract maybe for 50 points instead. All you have to do is just run this. You see, it didn't even take a second. And now if you open this longitude, you will see that you get the coordinates of 50 points 50 points excluding the starting and the ending point. So that's pretty cool, isn't it? So let me revert this back to 5 for the time being, because later on we will try to increase the number of the points just to make our section looks more precise. Alright, now it's time to make use of the pandas library. Now what I'm going to do is let me just make some space over here. Now I'm going to create a pandas data frame using this set of latitude and longitude values. Now let me define a variable called df. It's going to be pd.dataframe, and I can provide one column heading called latitude, and that's going to be this, and my next column will be longitude, which will be equal to this lon. Wait, this one should be a simple lat. Alright, now if I run this and if I say that print df, you see that I have now a pandas data frame which has the latitude and the longitude. This is basically a merging of those two different columns into just one pandas data frame, because it's easy to work in that way. Alright, so the next thing that I'm going to do is I'm going to create a geo data frame using these points. Now, since we have a set of points, the next thing that we can do is actually we can create a shapefile, alright? I mean, if you talk in the general GIS terms, you have the coordinates for 7 different points. So what you can do, basically you can create one shapefile. In geopandas terms, we call that a geodata frame. So let me create a geodata frame called gdf, which is going to be gpd.geodata frame. And first I provide the df, the pandas data frame, and especially I have to provide the information regarding this geometry column when you create a geodata frame. So that's going to be gpd.points from xy. That's going to be df longitude and df.latitude, right? Df, or you can, this is how we normally this is how I have been normally selecting columns when it comes to my tutorials. Or maybe just for a change we can also do df dot. It's actually going to be the same thing, df dot longitude, and the other one is df dot latitude. Alright, we can close this, and now let me go ahead and run this. And now if I try to see print gdf, you can see that now we have the latitude, longitude, and also this special geometric column which gives its unique geometrical attributes for it to be different from just being a pandas data frame. Why now it's different? Because if you say just gdf.plot, it'll actually plot the line for you in terms of the points, just like this, right? Now the good thing with having this kind of a global variable is that, let's say if you need to increase the number of points to, let's say, around 37, just a random number, and now if you try to run this and if you say that gdf.plot, you will see that it has 37 points actually in between the starting and the ending point. So that's pretty cool, isn't it? So what we have to do right now is simply go back to our, try to link this to our DEM, and for each point try to extract the elevation value, which will actually create us a 2D graph of the section. That's basically the whole gist of the tutorial. So, but let's go ahead, let's go to that point step by step. And we can go ahead and define the coordinate reference system for this as well. So I can do that by typing gdf dot CRS. That's going to be equal to and I'm going to define EPSG 4326. Basically this EPSG 4326 refers to the geographical coordinate system WGS 1984. You can just Google it if you are not familiar with this EPSG code. Right, you can run this, and now if I test gdf.crs, it's going to provide me with the WGS 1984 coordinate reference system. Alright, now what we need to do is, for example, let's say if you're trying to create a 2D plot based on the extracted elevations, you have a starting point which we can attribute as 0, 0. The y and x values are 0. You have a starting point which in terms of x values it's going to be 0, but then for each moving point, each point that you moves forward, you're going to plot that elevation based on the horizontal distance, which means you need to actually have the distance, let's say in meters or something, some kind of unit, because right now the unit that you are actually going to get from this is decimal degrees, and we are not really used to working with decimal degrees, right? So first let's reproject this shapefile into a projected coordinate system which carries the units meters, and from there we can directly calculate maybe the distance between 2 points and attribute that to later work that we are going to do. So first I'm going to transform this. Let's say I'm going to name it as GDF projected coordinate system, GDF PCS. That's going to be equal to GDF dot to CRS, and I'm going to specify the EPSG code to be equal to 3857. Now this is one of the coordinate systems. If I quickly show you what this EPSG 3857 means, yeah, you can just Google EPSG 3857 and that's going to result you with this one, the pseudo Mercator WGS 84 projection. But over here you can see that the unit that they're using is meters. Now this projection might be familiar to you guys because if you are familiar with, of course you are familiar with Google Maps, OpenStreetMaps, this Bing, ArcGIS, Esri, all these maps actually using this sort of projection. So even though you might not, even though you didn't know, in case if you didn't know this 3857 code, that's actually the corresponding projected coordinate system. So I'm just going to transform this from the geographical coordinate system into the projected coordinate system. Now if I run this now, yeah, before I run this script, let me just comment this out for a second, and let me just run this without the conversion of the coordinate system. And now if I say print GDF, you can see that we have information corresponding to a certain number of points, and over here you can see the geometry is now basically attributed using decimal degrees. But now after I run this one, let me run the projected coordinate system, the transformation to the projected coordinate system, and if I run this, if I say print GDF PCS, now you can see that despite having the latitude and the longitude in decimal degrees, now the whole geometry column has been transformed from decimal degrees into another coordinate system, and these units are basically in meters. So now if you calculate the distance between 2 points, that distance will be calculated based on meters, not decimal degrees. So that's what we wanted basically. So since that's out of the way, let me also add one more column to this GDF PCS geodata frame. Let me call this as horizontal distance, and I'm going to initiate it with zeros. So now if I run this and if I say that GDF PCS dot head, maybe let's say the first 10 entries, you can see that we now have another column called h distance. So basically this is the starting point. What I need to do is I want to calculate the distance between each point. No, not the distance between each point, the distance from the starting point to each point, so that later when I actually put another column over here called elevation, I can sort of plot the 2D graph, isn't it? My x-axis is going to be the horizontal distance and the y-axis is going to be the extracted elevation. So that's basically the idea behind it. So in order to calculate the distance from the starting point to each point, what I can do is I can actually write a simple for loop. GDF PCS dot and now what I'm going to do is I'm going to sort of plug in the calculated values into this is how we assign different values. For example, now during each iteration, if I put, let's say, 5 over here, that means actually I'm asking it to assign a certain number to each and every entry over here like this. Just for the fun of it, let's run this one and see what happens. Now if I say head, now you can see that it assigned actually number 5 over here, but yeah, I don't want to assign 5. Instead, what I want to assign is I want to assign the distance between this point and this point. Now if you calculate the distance between this starting point and the starting point, the distance is going to be 0, right? But if you calculate the distance between the starting point and the next point, it's going to be a certain number, and the next one is going to have the distance between the starting point and the third point, like that. So you can do that simply by gdf.pcs geometry 0. So let's have a look at what happens when you assign geometry 0. You can see that it actually sort of refers to the x and y coordinates, isn't it? And these coordinates are basically referring to the starting point. If you come over here, it's going to be 11319208.7, 113192.08.7. So these coordinates are actually referring to the starting point. That's why we have the 0th index over here. And now if I say that take the distance during each iteration dot geometry, but this time during each iteration I actually want it to refer to this index, because let's say during the first iteration it's going to take the value 0 over here, and in the next iteration it's going to take value 1. That means during each iteration it's actually going to take the distance from the starting point to the corresponding point. I hope you got the idea. And now if I run this, and we actually get sort of a warning, but I think you can ignore it. And if I go back to GDF PCS over here, and now if you try to see the h distance, you can see that we have the distance from 0 all the way up to 13,382, about 13 kilometers, that line which I drew before. Now this one basically works for any number of points. Let's say we want to just have 4 points. And now if I run this and if I check the GDF PCS, you can see that these are the 4 points that we refer to, and we have the starting point and the ending point, and these are actually equal splits along that line. So even this works for any number of points. Basically, if you want to have 200 points, I mean, when you have 200, you can imagine that the splits are going to be shorter than having just 4 points. But still the final number, the final distance from the starting to the end is actually going to be the same. Alright, I guess this concludes a major part of the tutorial. Now let's see how we can actually extract the values corresponding to each x and y. That's going to be quite easy, because you can see that we still have the latitude and the longitude values over here. because I'm going to extract the elevation values from the DEM, from the raster, based on the latitude and the longitude, because as I remember, the raster was actually in geographic coordinate system, which means we have to work with the latitude and longitude. But since we have the values for each row, it's going to be very, very simple.